Welcome, Matt Taylor here with another mathematics tutorial. Today I'll be doing questions 1 through 4 in exercise 2.4. Question 1 asks, state the transformations of y equals log to the base e of x required to produce these graphs. So it's asking, how does this, if you change this equation into one of these equations, how does that affect the graph? So we'll look at question A. If you put a plus 2 in the brackets, it moves it 2 units to the left. And if you have a minus 3 outside of the brackets, it moves the whole graph down 3, as you can see here. So it's being moved 2 units to the left from what the graph would normally look like, which would go up like this. In fact, I might draw that. So you can see the comparison. So the graph would normally be there. It's moved down 3 and across 2. So it's pretty simple. And then you have to sketch that. Question, it gets a bit harder with the later questions, but it's just adding dilations and stuff, which aren't too difficult. Question 2, sketch the graph. It's just like question 1, but you don't have to really state the transformations, just draw the graphs, labeling x and y intercepts. So x take 1, x plus 4. It's going to be moved 1 unit to the right and moved up 4 units. It's not going to have a y intercept because the asymptote is going to be at x equals 1, so it'll never hit the y-axis as seen in this graph here. So it starts, the asymptote is at x equals 1, never actually reaches that value there, and just keeps going on forever. The graph stops here because, as you can see, the graph, it's very, very small numbers when you get past really small fractions of numbers and stuff, and there aren't enough pixels on the screen to actually graph that so you could see how close it is to the asymptote. But it doesn't stop there. Question 3. Sketch the graph of each of the following functions, stating the exact values of x and y intercepts. So what it wants you to do is sketch this function. It's a pretty simple one, log base e of x plus 2, except what you got to do is you got to find x and y intercepts as exact values instead of decimals. So in order to do that, you have to solve for by putting 0 in as x and 0 in as y respectively to find the x and y intercepts, which I've done. So when x equals 0, it's simple, y equals log e to 2, which is, I've just put a 0 in there and you only get a 2 in that bracket, and that is a real number. We'll find out what that real number is, but it's essentially going to be less than 1, I think. Yeah, but greater than 0, so you've got a y-intercept that's a bit positive. That's the y-intercept, because making x equals 0. Y equals 0 is sometimes a bit harder, but you just have base, power, answer, so e to the power of 0 equals x plus 2. Rearrange that, gives you x equals negative 1, which is also pretty simple, I think. Question 4 is just solving. It's like simultaneous equations, but you can just do it using solve on the calculator if you didn't know how to do that. That's pretty much how you do it. So solving, because they're both y equals, you can make them equal each other, and then solve for x, which I've done. You get these two answers here, and to find the full solution, like you would do in simultaneous equations, you put the value back into the equation to find the y value. So I've showed that because I've made them equal each other, this is where they intersect. So if they intersect, they're going to have the same x and y values. So if I put the x values in, I'll find y values, and it's going to be exactly the same no matter which equation you put it into, so that doesn't matter at all. So the first solution is that, by putting this value, which I got here, into these two equations. It doesn't matter which one you do, but because they'll both give you the same answer. And then I've done the same thing with this other answer, and got the final solution. So that's how to do the first 4 questions for 2.4. Thanks for watching, and I'll see you in another video.